All right. Hey, everybody. Thanks for taking the time to join us today. I really appreciate you being here. This is actually a long time in the works. It's the first time we're trying something like this at Prismeer, but it is something we've wanted to do for a really long time. And that's just kind of creating a space to share like genuinely useful knowledge with people who design and build products every day. This first session came together pretty organically, actually. One of our customer development and experience engineers came back from like a local SolidWorks meetup and just raving about the talk that he had just seen. He's a big additive nerd, like a big 3D printing nerd. So I think it just kind of challenged his thinking or flipped the script for him a little bit of the way he approaches kind of these early design decisions. So I reached out to you, TJ. You were gracious enough to kind of walk me through the presentation, kind of share your thinking behind it. And immediately it felt like a really good jumping off point for these first conversation that we want to share, only because I think it's valuable no matter where you are. Like if you're in early concept development or you're deep into production and kind of looking for some lessons learned already. I just think it's super fascinating topic, and I'm excited for that you get to share it today. But before we jump in, like I think, we just give a little 30 seconds of context of like how this fits into the broader product lifecycle. And actually, before we even do that, I should probably introduce our guest, TJ Schnell. TJ, thanks for joining us today.
Yeah, thank you, Dan. Thanks for giving me this platform to deliver my presentation.
Absolutely.
Uh, so, yeah, so yeah, my name is TJ. I'm working for the DiMonte Group. So the DiMonte Group, we do physical product development from concept through commercialization. We have in-house industrial design, mechanical engineering, electrical engineering, and software development. So we can really work on a full range of different projects with integrated electronics or not. Um, and so I've had the opportunity to work on, tons of different types of products with them over the last 8 years, from, fitness equipment to different consumer products, some specialty medical devices, some power tools. Uh, so yeah, it's been a great company to work for, and we do some really exciting stuff. So I'm glad that we can share some of our knowledge through this platform.
Yeah, that's great. And I think the history of DiMonte Group and Prismeer goes way back. Like, I think we've been using you the entire
Hmm.
time we've been in existence, which is about 21 years now. But even
Yeah.
further than that, I think like your founder, Gene, and one of our co-founders' father, it goes back to like hockey days or something, but long,
Oh,
long,
sure.
long line of
Uh-huh.
history there. So it's great to continue working with you. I know the value that your group provides. It's fantastic. So
Yeah, thank you so much.
what I thought I'd do is just what you see on screen here is like a really simplified view of the product development journey. And this is just the path that many teams follow, but they might not have this exactly mapped out or formalized. And obviously, this looks way different if you're like a startup or if you're an OEM with a complete in-house design team. It's different. But typically, we'd start off with like a kickoff, followed by research and concept development, and from there you move into early prototypes, where these ideas are still malleable, flexible, but still evolving and just getting something in your hands before carrying on. And that flows into CAD development, production prototypes. That's kind of where we come in. That's a little specialty of ours. Iteration, final CAD, and that production handoff. As designs sort of mature or move towards that production, it's typically where we get involved, kind of helping teams take those designs, translate them into real manufacturable parts. But TJ, before we dive in, I'm just curious, like, does this line up with your thinking at all about how you guys think about this stuff? Or maybe where you get pulled in, or it just kind of, does it line up with how you guys approach things?
Yeah, absolutely. Like you said, every project is going to be a little bit different, but generally, this is a great process to follow here. Um, I mean, what's great about working with Prismeer is that, the Demanda Group works within all of the steps of this process, but we, don't have the prototyping resources necessarily to do, full prototype runs of 5 to 10 parts. Manufacturing those parts, we can assemble them in-house. But that's where we'd go out to Prismeer for maybe the early prototypes at step 3, definitely the production prototypes at step 5. Have you guys manufacture the parts before we do, a test fit and assembly and testing in our in-house laboratory. So what's also great about, working with you guys for the prototyping phase is that you guys are also have, contract manufacturing, full, production run manufacturing capabilities. So we found that it's really helpful to use the same vendor for production prototype as for the production handoff, because you learn a lot about the manufacturing process and how it could be improved at that, step 5, where when you go to step 8, it's already been figured out by one house, and you guys can just kind of run with it.
Yeah, like we were along the journey all the way, so it's like we're all on the same page. We all hit the same
Hmm.
roadblock, same problem. So, that's great to be able to work that way, and you're not sort of rehashing everything from the start at every level you get to.
Yeah, absolutely. And also working with you guys, because you have all of these different capabilities, a lot of the
Right.
times we're designing a product that has little sheet metal bits in it. It has maybe some plastic enclosures. And so we can work with you guys to do all of the parts and just, cut one check, do one purchase
Yeah.
order, and have it all come in the same order rather than reaching out to a bunch of different, like different sheet metal house, different house for cast urethanes,
Yeah. And do that
3D prints,
whole
this and
knowledge
that.
sharing again and again and again. Yeah, that's great. Makes
Yeah,
sense. Yeah.
exactly.
Awesome. So I say we get into it here. The title of the talk is From Clay to CAD. I'm so excited to talk about it afterwards, but I'll have a few questions afterwards. I got a couple questions from people who were at your first talk. So some follow up there. And you take it away, and I'll meet you here back after the show.
Awesome. Thank you, Dan.
Great.
All right, so this is my presentation from clay to CAD, how to turn a clay mockup into a 3D SolidWorks model. In this presentation, I'll be running through this workflow that we use all the time at the DiMonte Group. And it's the process of creating a clay model and solving all the problems in real life using that clay prototype before 3D scanning it, and then using that 3D scan as a reference to create your CAD model. This process has a bunch of applications. Like I said, we use it constantly at the DiMonte Group. It's a great tool to have in your toolkit, regardless of what you're designing. It's especially fantastic for designing some ergonomic applications, but there's a lot of different ways you could use it. So in this first example here, this is a nail gun that we designed, where we used clay to model the handle ahead of going into CAD. So there's a bunch of factors here, like the center of mass and also the form and the size of the grip here. So figuring that out in clay was really helpful. Some other examples are these hooks here and chain shorteners. So these have some very organic and flowing geometry, which is very difficult to model in CAD. So we're able to figure out that organic geometry and how it interacts with the chain and other things before going into CAD and modeling it. So we only had to model it once. And then lastly, this example at the bottom here shows that you don't even need to be using clay to use this sort of process. In this example, we were creating this power tool here where we created this very low fidelity kind of hobbled together mock-up by cutting up and kind of assembling a bunch of other power tools. And that was able to kind of approximate the size and where the center of mass was going to be for this tool. And then we 3D scanned that and used that 3D scan as an internal reference to model and sketch and figure out what our end geometry was going to be. So I decided to use this process to redesign the Nintendo 64 controller. Partially because I'm just really nostalgic about it, but also because it's just a really kind of unusual controller with this three-handle design. Like you almost need three hands to operate it, so it's pretty unique. It's before they were really figured out how to make kind of modern two-handle controllers with two joysticks. You can see that the competitors here are doing some really kind of unusual stuff as well. So there's a bunch of kind of unusual third-party alternatives to the stock Nintendo 64 controller. They just get stranger the more that you look at them. There's a few of them that are doing the two-handled thing, but not super well. And generally, I've found that all of the third-party controllers tend to be a lot less durable. They have less precise joystick tracking, and they develop stick drift over time. So I knew I really wanted to use the internals of the stock Nintendo controller, but just redesign the skins to make it a two-handle design that functioned the same as the original controller. So the original controller has two grip positions. It's got this joystick grip position where you're using your left hand to toggle the joystick here on the middle handle. And then it's got this D-pad grip position where you're interacting with the D-pad and the left shoulder button, and you're holding onto this left handle. But this three-handle design it makes it difficult to switch between using the directional pad and the joystick. You have to move your hand entirely off in a way and back onto the other handle. It also makes it so that the left shoulder button up here is inaccessible when you're using this kind of joystick grip position. And also on top of that, this was obviously designed for kids and all sorts of different hand sizes, where if I was going to design a controller for myself, I would like it to fit my hand specifically. So that's what I did with my design. And you could see the reason behind my design being sort of asymmetrical here is because it still accommodates these two different grip positions, but instead of moving your hand entirely off of the handle, you can just slide your hand up and you're using the D-pad, and you slide your hand down and you're using the joystick. And in both of those grip positions, you can still use the shoulder button. All right. So my first step here in designing my controller was to do some reverse engineering. I took apart an existing Nintendo 64 controller just to figure out which of the internal components I could use and if I was going to have to reinvent anything or scrap anything. Unfortunately, what I found is that I could use all of the same internal components. So I was able to use the same PCB, the same joystick, and all of the internal buttons on the top side and the shoulder buttons. So it made it a lot easier on me. All I had to do was redesign what, the skins and how they interact with these internal components. So I started by creating 3D models of all the internal components. I knew I was going to have to do this anyway to create an assembly in CAD. But what it ended up allowing me to do was to create sort of an internal 3D printed framework, which I'll show in a second. So when I was modeling these, it was important for me to just model the critical surfaces and faces. I didn't have to model every single little detail. For example, on this PCB here, I didn't model every single little capacitor and bit. I just modeled the kind of general volumes to know that I wasn't interfering with anything on that board. So after that, I used those CAD models to 3D print this inner framework, this sort of inside skeleton that I built up clay around to create my clay model. And this was a fantastic route to go down for a couple of reasons. First, it allowed me to kind of locate where all of my buttons were going to be. So there's no guesswork there. And also those buttons, since they were poking through the clay, they acted as a datum for aligning my 3D scan. If you've worked with 3D scans before, you know that they don't come sort of pre-aligned to your coordinate points. So you have to align them yourself. So just having those datums made that a lot quicker and easier. And the clay that I use for this is called Castelline clay. It's made by a company called Chavance. And we love this stuff at the DiMonte Group, specifically because it's like rock hard at room temperature. But then you can throw it in the microwave or use a blow dryer and a heat gun and warm it up, and it starts to soften. And if you get it, it kind of softens to the point of like Play-Doh. And if you really nuke it, then you could get it to be basically a liquid and then use it for casting if you wanted to. But yeah, heating it up enough, this stuff is amazing. It's infinitely reworkable, so you can take all of the scrap pieces and combine them and mix them back up together and use them again, or melt down old prototypes and use them for something else. It's a great medium. And what's great about it being so hard is that when you're modeling something that you're dealing with ergonomics, like a grip, you don't have to worry about like gripping that prototype too hard and then deforming it. You can just use it as if it were some sort of a plastic component. So it's really nice stuff. And I was able to get, when I was sculpting, I was able to take this amazing time-lapse video here. So actually, to take this video, I duct taped my phone to the ceiling. And I'm so glad that I did, because I really like the way that this video came out. But it really shows the process of starting with that internal 3D printed framework and then just globbing on clay around it until I'm kind of starting to get to the shape that I want to. So you can see I'm just globbing on more clay, shaving some off. I've got this microwave in front of me that I'm kind of constantly sticking balls of clay into and heating them up so that they become more workable. The working time for this clay is generally between like 5 and 15 minutes, kind of depending on the volume of the clay that you're dealing with. So you can see here I'm starting to get a little bit closer to what I want, going in with some sculpting tools and refining things. And then at this point, I've got all my surfaces mostly where I want them. I've started to sketch some UV lines on the surface to reveal what that surface is really doing. And then I'm doing some fine detailing with a blow dryer and trying to smooth things out till I get to the final model. So this is a video of that final model. At this point, it had taken a beating. You could see some of the cracks and gouges that are happening in the surface. This was after I had already scanned it, but it does a good job of just showing what that might look like. So that's the clay sculpting. If I were to redo this, there's a couple of things that I would have done to improve my workflow. So the first tip is that I would have offset all of the faces that I don't want exposed by 1 nominal wall thickness before 3D printing the internal reference. So what that means is, in the example of this joystick here, the actual part geometry in yellow below, I would have offset all of these surfaces and printed the kind of pink, larger geometry. What ended up happening is, because I didn't do this, I ended up needing to create all of these little internal cuts on the inside of my nominal wall thickness. And besides just being really annoying to model, it actually compromises the structure of the part, and you can kind of start to see that through the part a little bit in those areas if you're deciding not to finish it, the 3D print. So this would have been a great technique before building up clay on top of that framework. Another workflow tip that I would have done is to reinforce the weaker sections of the model using my internal reference or using just anything really. You could see evidence of a model repair, and you could see it in the video as well, like where it was cracking along this handle here. There's kind of this thin section, this stress riser through this area, and it ended up breaking. So if I had extended out my internal reference to act as just an internal like rebar or something in concrete, then that would have helped support that. I could have also just taken some chopsticks and like broke them in half and stuck those in there too. That would have worked. So once you have your clay model finished, and you have it where you want it, you've thought of like all of the design factors, and you're ready to go into a scan, so you can start working in CAD. You can 3D scan your model. At the DiMonte Group, we have these really nice high fidelity scanning tools that I was able to use. You end up sticking a bunch of stickers on, they act as datum points, and it just spits out like a mesh point cloud file, like an STL. So that's what you've got here. So modeling from a 3D scan is definitely a bit of an art. There's some things that you could do to make your life easier. And it's about really interpreting what's happening in your clay model and choosing what you want to follow and choosing what you want to ignore. Because your scan is not going to be perfectly smooth. So just using your judgment to understand what's important. So when you're modeling, you want to find the smooth average of your lumpy clay surface. I call this finding the trend line. So finding the trend line is just like looking at a trend line on a chart. You want to find that smooth average. So you can see in this example here, I've got this kind of lumpy green clay surface, but I know I want smooth geometry in my end part. So I'm choosing to look at this and say, hey, that looks like more or less flat. So I'll just make this a line, make that like linear. And then it starts to have some curvature here and dip in. So I'm adding this smooth curvature with curvature continuity, as you can see by the combs represented here. So it's about, just finding that trend line between your lumpy average. So when I was modeling this, a good strategy is to kind of look at it holistically and then start with what you know and then fill in what you don't. So before you even open CAD, you want to have a plan for like how you're going to model this thing. So you want to start by, in my case, I wanted to know what's going to be mirrored, what can be symmetric versus what is going to be asymmetric features in the model. You want to be able to mirror as much as possible because it saves you a lot of time modeling something twice. You want to, in my case, I wanted to determine how the shrouds are split up. So I wanted to find the split line that separates my housing halves. I knew I was going to do the same clamshell where it had a top shroud and a bottom shroud. So I had to find where that split line was, where were things getting broken up. And then I also had to think about which surfaces are going to be the most important. So start planning and modeling like those target surfaces being those like really first surfaces that you model. For me, I knew it was going to be the surfaces in blue here, with the primary surface being like that top kind of button surface, and then also those two grips were going to be super important for me. So looking at symmetry, there was a few things that helped me determine which side should be my primary side. First off, when I was looking at the surface finish, which surfaces had really smooth, nice clay scan geometry below. And then which surfaces also had more information to draw from. So looking at the top surfaces, it was pretty clear I wanted to pick the right side as my primary side. because the left side had this big plateau around the D-pad, which doesn't show me anything about the surface, the underlying surface below. And I knew I wanted everything inside of the green to be symmetrical on my final design. So that led me to use the right side as my primary side. Then also looking at the bottom, the right side was better too. On the left, I had all these kind of weird lumps and things. I had this lump around this area, which wasn't that descriptive. So I ended up like drawing from the bottom side as well, that the right could be a great primary side. And then I had to determine my split lines. Where was my clamshell going to split, right? So I extruded a surface from the top plane. You can see here, these were the kind of splines, the sketches that I drew, and extruded it. And that kind of shows you how much of the clay is poking through that extrusion. And it allows you to find sort of like an average split line between those two. It can be kind of difficult to interpret the clay because it's so lumpy. Like doing some sort of a draft analysis, it's just going to end up looking like radiostatic. So doing something like this it's a helpful kind of guide and visual guide to do things like this. Then to determine my top surface, I wanted to look at what was happening on the existing controller. Because I was using all the same buttons, I needed to follow the curvature of those buttons. So in this case, the button tops are curved. If you're looking at it from sort of like a front view like this, they're kind of curved in this direction. But then looking at it from a right side view, they're curved in this direction as well. So I knew I wanted to have my top surface curved in both those directions. This is a sort of a method that I invented to help me find where I am relative to the clay. And that is to set up some offset surfaces on either side of our actual surface here, and then toggle the visibility of the three surfaces to see how much of the reference scan is showing. So I have my final surface here that's way oversized, that's going to end up getting cut back, but I offset it above 20 thousandths or half a millimeter and below by the same amount. So you can see when it's offset above, very little of the clay is poking through. I just have my buttons poking through as intended. And then with the offset below, there's like a bunch of clay poking through. And what that tells me is that my final surface is within plus or minus half a millimeter or 20 thousandths of the clay. Another technique that I use to help interpret what's happening in the clay is just to use section views. So in this instance, I was drawing the spline, which helps determine the grip. And I just created a section view on the same plane, and it just helps really describe or reveal what's happening in the clay in 2 dimensions as well as 3 dimensions. So this was my final CAD model before I went and shelled it. So seeing all the outside surfaces here, it really kind of shows how close to the clay I'm getting. What you want to be seeing is exactly what's happening on this grip here, where you have lots of little islands of clay poking through. The amount of clay showing and the amount of the final model showing is generally about this like 50-50, about the same amount. This is a really good example of following a clay model very closely while still getting some very nice smooth final geometry. And you can see a very similar thing happening here on the other grip too. We have generally about the same amount showing through. And then you can see the difference between how symmetrical the clay is versus my final model. Because we know the final model is perfectly symmetrical and that I followed this primary side. So this surface is looking really good. And then obviously I'm choosing not to follow this surface because it's not symmetrical. I could have modeled something that followed that, but then my final model wouldn't be symmetrical and nobody wants that. So it's about making those conscious decisions. If you're not going to follow the clay, it should be a conscious choice. So here is that same final model with offsets above and below. So on the left here, I've offset 40 thousandths or 1 millimeter below. And on the right, I've offset above. And you can see that I'm more or less within plus or minus that millimeter of my final model, with a few exceptions. Here, you can see, again, this is an example where symmetry was more important than matching the clay. And then in this instance, I had this kind of lump in the clay that I hadn't noticed before, and I wanted that transition to be smoother to kind of match what was happening on the other side. So I chose actively to ignore that. And then in this case, I found this kind of trench that was in the clay model that I hadn't noticed, and so I chose not to follow that consciously. So once you have your final model, how you like it, my next step was just to add all the internal features, modeling all of the ribs and things that actually hold all of the internal components in place. In this case, I think it's great to just, if something is working well, just steal it. Look at your reference part, and if those ribs are working, then just do the same thing, follow the same thicknesses, try and do something similar. So that's more or less what I did. I bulked up some areas for 3D printing because my 3D prints are not going to be as rigid as an injection molded component. But yeah, just modeled everything in place. And then the next step was to prototype it, to test it, because nothing is ever going to work perfectly on the first try. It's worth doing some iterative prints to make sure that everything's assembling correctly and make sure that you've improved what you can before going in and doing your final production run, or in my case, your final finished 3D prints. So some things that I found was there was this little assembly interference when trying to swing the Z button into place. So it was interfering and hitting that rib, so I ended up just like knocking off that corner there. This wall section was getting too thin to resolve, so I ended up just bulking that up a little bit around the joystick in this area, just making it a little thicker so it could fill out. And then also the shoulder button and main cable were not well constrained, which was making assembly difficult. You have to align a lot of things between the bottom and the top clamshells when you put them together, and these kept kind of jumping out of place. So I just added some taller ribs, just more constraint, and some like kind of wire retention features, so that it became a lot easier to assemble the two clamshell halves together. So after making those improvements, it was time to do my final 3D print. So I chose to print this with the outside facing down, because it was just easier to peel the support material. I wanted all these rib features also to be resolved nicely because they interact with those internal components where they want to have a decent surface finish. And the A surfaces, the outside surfaces, don't really matter what the surface finish is because I knew I was going to sand it and fill it anyway, so it didn't really matter for me. So here's that final print and finishing. You can see here that I filled with Bondo and then multiple layers of sandable primer, going finer and finer grit each time, then doing that final coat of primer. This is what it looked like. Then it was just a simple spray paint job, and this is how it came out here. This is definitely a labor of love. It was my first time finishing a 3D print to this degree. And there's a lot of like fine sanding and some really concave nooks and crannies. But I'm really happy with the final result here. I don't think it's perfect, but I'm pretty happy with it. And it's especially great that this is like a final playable controller. It works exactly like a Nintendo 64 controller would, but with this new two-handled layout. I was also really happy with the way that my controller maintained the ability to easily wrap the cable. With the original controller, it's really easy to just kind of like twist your wrist around, wrap that cable up, and then toss it in a bin. So my controller does the exact same thing. It also sits flat on the table, which is another great thing that I worked out in the clay before going into CAD. It's one of those things where if I had been working in CAD from the start, I might have gotten to this step and then realized, oh crap, it's a little bit wobbly when you set it on the table. But because I had that physical prototype up front, it's something that I solved at that step and didn't have to go back and fix later. So, and that's my controller. There's a couple of places I would like to take the project next if I have time. First is refining the SolidWorks feature tree. Currently, it's just a little bit unstable, and it'd be nice to have it as a reference that I could send out to people. I would like to add some rumble pack features, so I chose to kind of skip having an opening on the backside here where you have some accessories like this rumble pack. I don't really use those, but if I had more time, I'd maybe add those features back into the controller. I have the space to accommodate them, so. It would be awesome to make a soft tool to do some a silicone tool for cast urethanes. I've ordered a bunch of cast urethanes. I've designed cast urethanes before, but I've never made them myself. So it'd be really fun to, I think, make a silicone tool and hopefully be able to cast like double digit amount of prototype housings out of it. That'd be super cool. And then the last step would be to add a logo. I think the design is just begging for some branding right in the middle, but that's about it. So the final takeaways here are make sure that your clay is ready before scanning to 3D. You want to consider all the relevant aspects of your design while you're working in the clay. Try to think, really critically about what the product wants to be. Make all of those really conscious decisions in the clay so that when you go into the CAD, you have a really solid reference to follow and something that you know is going to work. Taking a little bit of extra time to smooth out the important clay surfaces saves time down the line. So if you have really nice, clean, and smooth surfaces, it becomes really easy to interpret when you're in CAD as opposed to having something that's really lumpy. So taking that extra time up front to smooth those out before you scan it, that's a good step. And then making preliminary mock-ups if needed for exploration can be really important. In my case, I created this preliminary mock-up that's shown here. This one did not have any sort of an internal skeleton or anything. I just put some clay in my hand and started modeling it to see kind of sitting next to a Nintendo 64 controller, like the form it might take. That ended up inspiring the final form and kind of telling me some things that I might not have realized if I just gone straight into the end clay model first. And then the next thing is a little bit counterintuitive to what I just said, but the clay is just a reference. If you're in the CAD and you find that something in the clay isn't working or you need to make a conscious decision to ignore something in the clay, you can do that. It's important to know like when to follow that clay and when not to. So in my instance, following one primary side and then ignoring that they were asymmetrical and understanding that I wanted my final CAD to be asymmetrical. And then in other instances, like finding that nice curvature is more important than following every single little lump and bump in the clay. And then also that manufacturable geometry is more important. So if there's areas of the clay that are not drafted, where you need to have draft for injection molding or some other method, it's important to understand how your parts are being manufactured and follow that as opposed to following exactly what's happening in the clay. So that's my presentation. I hope that you guys learned something, and I understand that there are some questions. Thank you very much.
Thanks again for sharing all that knowledge, TJ. So onward to a couple questions here. This one's for me first, but the thing I'm most curious about is how many controllers do you think you broke in the process? How many did it take to get there?
Yeah, I went through quite a few. I think it ended up being like 4 or 5 at the end.
Okay.
But I kind of figured out that because I'm scrapping the shell for these things, I could just buy them on eBay, ones that are not in the best condition but
Okay.
have working boards, and save some money that way.
Right. Yeah, they're pretty expensive now. It's like retro equipment coming back in vogue. That's great.
Yeah, exactly.
Okay, so this one came from David. So after having gone through this process, do you think you've gained any intuition for ergonomics where you skip the clay modeling if you were to design a different part, like a drill handle or something like you mentioned on in your presentation?
Yeah, that's a good question. So I've definitely gained some more intuition for ergonomics, but I'd say this is not a skippable step. So if I was going to be designing like a drill handle for one of our clients, this is just an amazing tool to be able to figure out the ergonomics for that. Every product is going to have its own set of ergonomic constraints, and so that's why it's important to figure things out in real life with a clay prototype. Because that way, yeah, you're solving those problems in reality. You could touch it, you could feel it, you could give it to other users that maybe have different ergonomic factors than you. So
That's true. Yeah.
it's just a fantastic tool for developing ergonomics, especially for handheld type products.
Yeah. And like before you're going into CAD, you can still be adding and subtracting right, in your hand basically with it, going back and forth. So that's cool.
Yeah, that's exactly right.
So something that we typically see a lot on our side is like customers that will, iterate pretty quickly through 3D printing. But what do you think the advantage is here of like, using this process over say starting in CAD and going through multiple 3D prints?
Mm-hmm. Yeah, it's super interesting. I mean, 3D printing is an amazing tool, and the
Hmm.
technology is just getting faster and faster and better. But in this instance, I think that clay is still winning out because it's just going to be much faster. There's a lot less downtime of working within your 3D model or waiting for things to print. When you're working with the clay model, you can get everything exactly how you want it in the clay before going into CAD. What that allows you to do is just modeling it once rather than creating one model and then making small tweaks that might break features and create a mess. So yeah, we use this process all the time at the DiMonte Group, and it's a fantastic way to go.
That's awesome. Yeah. This one's near and dear to our heart, but at what point are you considering design for manufacturability? And what are your thoughts on that generally, DFM?
Hmm. We consider DFM from the get-go. At the end of the day, anything that you're designing is hopefully going to be a manufacturable product. It's going to be a physical thing that needs to be created.
Yeah.
So yeah, I was thinking of manufacturing from the get-go. Another great aspect of this process is that you can, when you're figuring it out in the clay, you can kind of consider all of those factors from the beginning. You could even etch in like little parting lines to your clay or drawing it with pencil to figure out exactly where your part splits might want to be.
Right. Makes sense.
Hmm.
Last one for you. What if some of our audience wanted to use this clay to CAD approach but didn't have access to that cool 3D scanner that we saw?
Oh yeah. So I know that the technology in iPhones is getting a lot better. They have some like LiDAR just baked into them nowadays if you have like a newer iPhone. So there's some apps you can download, like Kiri Engine is one that I found. I haven't played with these yet, but I plan to. So if you have a newer iPhone or a friend with a newer iPhone, you could go that route. Otherwise, the DeMonte Group is happy to 3D scan stuff for you, whether it's a clay model like this for your project, or if you have some tolerance analysis or a manufactured article that you want to inspect. We have this amazing 3D scanner and we want to get use out of it. So you feel free to reach out to us.
That's awesome. I didn't know that that was a service you provided outwardly. That's great.
Hmm.
Because I mean, sure, iPhone, and I've played around with that technology too. It is pretty cool. I imagine that the
Hmm.
fidelity, the high definition scans would be the way to go if you're serious about it for sure. But that's great that you're providing that service.
Yeah, absolutely.
And lastly, that's it. So thank you for taking the time to do this. I wish you the best of luck giving this talk and the more technical talk at 3D Experience. But yeah, this is amazing talk. Thank you so much for your time. Really appreciate it. I hope the audience got a lot out of it. I know I did. And just appreciate your time on this, TJ, on this first one. Thanks for kicking it off with us.
Yeah, thank you so much.